today we are going to discuss a case study of a welder flange. Okay, as we normally know, welding is a joint process. AWS, that is American Welding Society, has given a proper definition for this welding. It's a process of two materials. Either it can be a similar material or dissimilar material. Means you can weld even steel to steel, means stainless steel to stainless steel, you can weld similar welding. If you are welding stainless steel with carbon steel, it's a dissimilar welding. So by doing this type of welding, sometimes you can use filler metal or without filler metal. Sometimes you can apply pressure for welding. Sometimes you may not apply pressure. So depend upon the welding process, you can there are so many welding processes. Depend upon the usage of this filler metal, pressure, and some other extra auxiliaries, we can differentiate many type of welding process. But sometimes due to some fatigue error or some material resistance or some treatment issues, there are some failures that can be occur in the industry. So and that type of case study we are going to see. This has happened on a welding flange, not exactly due to welding, but it can sometimes the failures can occur due to other processing. Okay, we'll see over it. So this is the introduction. So they have this is the component of welding flange, which has a 4-stage microstructure, which is installed in the high density polyethylene loop reactor. So this is the dimension, and the material is ASTM A105. As I already indicated, the ASTM is American Society of Testing Materials. Right. So next.
Here, while coming to the visual inspection, in the first figure, we can analyze that the flange cracked in the transition between the conical and the cylindrical part of the weld flange. Next.
So this is look like a small flange. So due to the temperature variation, also temperature variation. So due to sometimes it may happens due to the temperature variation or the non-homogeneous temperature distribution, some cracks may happen. So we will see deeper on why this welding this failure has happened. Okay, next. So previous. So this is the flange actually. So this is the crack where it is actually happened. Next.
So metallography means that it is the study of microstructure and the pores where the metal in the metal it occurs. So metallography is done using the set of microscopes as typical in the core which we have been done. So metals are the basic thing which we are going to be studying in metallography. So here 24 inches flanges for high density polyethylene reactor has not been normalized here. So the coarse grain microstructure is occurred here. The difference between minimum and maximum individual American Society of Testing Material as verified measured per flange is from 1,3 to 2,3 is mentioned by ASTM.
So here, as a friend said, this is a post grade structure, right? This is a post grade. As the name post grade comes, when compared with the fine grained material, post grade material have a lesser strength, so it can be broken, right? Next. So this is the post grade structure of the flange that has been cracked. Okay. Next. So this is an exact view. You can see this is the crack moving out. So this is the we have removed it and see what is the cracks. Next.
For the chemical analysis, the chemical composition of the carbon is maximum 0.35 and the silicon is around 0.10 to 0.35 and the manganese is 0.60 to 1.05.
So coming to mechanical testing, so the impact toughness of the current testing we have done. So we have 27 joules in the higher, 27 joules and plus multi-degree in the top. So on the minimum
At the temperature of 20 Celsius, the impact strength is 20 degrees.
at the minimum operation temperature it's minus 29 degree Celsius and 10 joules. So this is our mechanical testing.
So for mechanical testing, we have find these both data. Next.
The flanges are not being treated properly, and after closing the script, the accommodation condition that all the plants have been operating.
So here it is mentioned that it has been not treated properly. Means see, when we come to see, don't take a material as an example. Take a small vegetable as an example. If you take potato as an example, if the potato is not boiled properly, we can see a hot end part on one side and a soft end part on the side. Means we cannot use it properly. We cannot eat. So the same way, if it is not heated properly, if it is not heated properly, then also there will be, see, as I already said, no, there is if there is any non-homogeneous material temperature distribution also, it creates the case failure.
As we discussed, the causing